Hello, I welcome you all. The problem reads, determine the magnitude of the resultant force acting on 5 kg particle at the instant 2 is equal to 2, t is equal to 2 seconds. If the particle is moving along the horizontal path defined by the equations r equal to 2t plus 10 in meters and theta equal to 1.5 t squared minus 60 in rads, where t is in seconds. This problem is coming from the Engineering Mechanics and Dynamics, 14th edition by R.C. Hibbeler. So one of the catchwords here, it is this. This is the catchword. It is in the horizontal path. Okay. It is in the horizontal path, which also would mean plan view. Okay. So it's in plan view. It's in plan view. So it means the weight of this particular particle will be acting through the screen. So we'll not consider it when it comes to the free body diagram. Again, I repeat, the free body diagram will not be able to see when we draw it in horizontal plane or in plan view. We use it in the calculations, of course, but it is going to be acting inside the screen because it's in plan view. If it was in vertical plane, then we would have assumed that the weight is acting down. But in our case, the weight is acting inside the screen. So it makes the problem, in fact, much easier. All right. So now what are we being asked here to find? We are being asked to determine the magnitude of the resultant force. Okay. So this resultant will come as a result of F theta, okay, F theta and Fr. So our resultant force will just be equal to F theta squared plus Fr squared. This will be our resultant, right? Okay, it's our resultant. So we are able to find the resultant force from the reactions, right? So these are the reactions of the force on this particle. As the force is applied on this particle, the particle reacts, and we have these two forces, Fr and F theta. We know that when a particle is in static equilibrium and unbalanced force acts on that particular particle, the particle experiences acceleration and then it moves, okay, in the direction of that particular force, right? So the acceleration will change the magnitude of its speed, or it will change the direction, okay, of that particular particle, or it will change both its magnitude of its speed as well as its direction. Right. So these F theta and Fr are the resultant of the force exerted on the particle. So we can use the same resultant, okay, forces to find the actual force, and this is what we are going to do in this particular case. Right. So straight away, we'll start now working it out. So we have R, which is just a linear function of t. All right, and theta is a quadratic function, right? All right, so let's find the inputs that we're going to use to calculate Fr as well as F theta. So Fr dot is just going to be equal to, this is derivative of R with respect to t is just 2, okay, and F double dot is just going to be equal to 0. Then we do have theta here, which is quadratic. It's 1.5 t squared minus 60. And theta dot, this is just becomes 2 by 1.5, which is just a 3. Which is just a 3. I can write it in advance. It's a 3t minus 6. And theta double dot is just equal to 3. So we have everything that we need. So now what we need to do is to find AR. Our AR is just R double dot minus R theta dot squared. Okay, we do have all the inputs. Do we? Not all of them. So let's work out some of them. So theta dot at t equal to 2 seconds. We are using this here. This just gives us a 0. Okay. So therefore our AR is just 0 minus R. Let's find R also at t equal to 2 seconds. We're using this here. So this just gives us our R when t is equal to 2. This is 2 by 2, 4 plus 10, 14. So this is a 14 t squared. I mean the theta dot squared is just right. Therefore our AR is just equal to 0, right? Because this part will all be 0 also. Okay. Right. So having said that, let's go to A theta, which is just equal to R theta double dot plus 2R dot theta dot, and our A theta is just going to be equal to our R is equal to 14. Theta double dot is a 3 plus 2R dot. R dot is a 2 and theta dot is a 0. Okay, so all this part is 0. Therefore A theta is just going to be equal to 14 by 3, and this gives us a 42. Okay, this gives us a 42. Right, so what do we have now? Let's work out, apply the equations of motion. So summation of forces in the area equal to MAR. FR therefore will just be equal to M, and our M is just 5 times AR, which is just equal to a 0, and this is 0. Then we have summation of forces in the theta direction. This is just equal to MA theta, and this is F theta is just equal to 5 by A theta, which is 42, and this is equal to 5 by 42. This is equal to 210. Therefore our resultant is just equal to FR square root of FR squared, small r there for radio, plus F theta squared. Therefore our FR will just be equal to 210 newtons. Okay, I guess this is about it. We found the resultant. The magnitude of the resultant force acting on a 5 kg particle. I hope this video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and sharing my channel. Bye bye, and I'll see you in my next screen.